Hey, what's up guys? So I just wanted to make a quick video here giving you the basics on stepper motors, which are different from regular motors in that you can control the shaft in a very precise way, which is why you find these kind of motors in 3D printers, CNC machines, printers and scanners, and any kind of machine that you really need to move something in a really precise way. They're a little bit more difficult to control, but I'm going to show you how to control one just using switches. And I've got one mounted here with a little dial here so that we can actually step through the sequence and control a stepper motor directly just using switches. And you should be able to take that and then write your own code for the Arduino or any other microcontroller to control a stepper motor. So let's first go to the whiteboard and talk about the theory a little bit. Okay, so what I've drawn up here is a very crude and rough diagram of a stepper motor, and the basic idea is the same. You know, we're trying to control the magnetic fields in the stator to control the rotor, okay, which is connected to the shaft. So by controlling these magnetic fields, we can rotate that rotor around clockwise or counterclockwise by sequencing the magnetic fields. And what I'm showing here is a bipolar stepper motor, and they call it a bipolar stepper motor because you need two polarities essentially to be able to drive these coils. So I need to drive this coil either positive and minus like that, or minus and positive. So it's bipolar. I gotta flip it both ways. Same thing over here. So you have two sets of coils, and typically you'll find bipolar stepper motors with 4 leads, right, for the two sets of coils. Unipolar stepper motors are basically the same idea, except that they give you a center tap wire that come there. And sometimes this wire here is actually connected internally to this one's center tap. Okay, so then you would have a 5-wire unipolar stepper motor. The reason they call it a unipolar is because then, oh, this drawing's getting a little complicated here. Okay, so I just redrew that so it's a little bit easier to see. That was getting a little busy. But basically what you would do with the unipolar stepper motor is you connect the center tap to your high side voltage. So I'm showing it here connected to VCC. And then if you want to control the polarity or the fields, you basically just have to ground this. So if you wanted that one, you would control that field, and then this is positive minus. And then the same thing over here. If you wanted to switch this field, then you let up on that, and then you ground this side here. So then it's positive minus, and then the field direction changes, and you're able to basically control the polarity. It's a little bit easier to control unipolar stepper motors just because you only have 4 transistors, right? You just have to ground either one of these sets of sides of the coil. On the bipolar stepper motor, since you have to control the whole polarity, you actually need 2 full H bridges, okay? So that's basically the difference between the unipolar and bipolar. The bipolar stepper motor can deliver more torque because you can take advantage of the entire coil, right, since you're controlling over the entire thing. But since you have the entire coil to control, which gives you more torque, it's more inductance, so that may hurt you if you're doing a high-speed application where you really need to rotate this fast and apply the magnetic field and remove it quickly. So now let's just talk a little bit about sequencing. So there's, you may hear when you're looking at bipolar stepper motors or unipolar stepper motors is half step or full step or microstep, and that is how you step the rotor by controlling the magnetic fields in the stator. So if we just look here for a second and say that this, if we just energize this coil at some polarity, the rotor will lock on to wherever that is, okay? And then if we remove that voltage across that coil and then apply voltage across this coil, the rotor will step a full step. So that's full step control, and it may rotate this way. If it was the other direction, this polarity was flipped, then it would go in the opposite direction. So that's sort of how you sequence it. And once we go to the breadboard and I show you how to control a stepper motor with just switches, you'll actually see that we have this coil locked in, and then if we let go and then apply voltage across this coil in one way versus the other way, we can control the direction. Okay, so that would be a full step, and usually these stepper motors are rated. There's the markings on the stepper motor will tell you what a full step is, in degrees, and I think the one I've got is 1.8 degrees. So what a half step is if we left the voltage applied across this top coil and then applied this voltage here. So now you have both coils energized, and instead of it rotating full 90 degrees, the rotor in there, it would rotate in between it, like right here, and that would be a half step, or not a half, yeah, a half step. Okay, which is nice too, because that gives you a lot of torque in there, since you always have these two coils energized. Okay, so now let me well, one of the things we're not going to get into too much is microstepping, but microstepping is basically controlling the voltage in an analog kind of way to move the rotor within any part of this region here, within that half step. So we won't get into that too much, but I think at this point we're ready to move on to the demo. Actually, let me give you a quick schematic of what I've got over there. Okay, so basically this is the schematic for what I've got over on my bench here to control a bipolar stepper motor. So it is 4 wires. I've got the 2 H bridges laid out on my breadboard, and you got to make sure that you add these diodes in, these anti-parallel diodes, because as you're applying the voltage to the coils, you're building up that magnetic field, and then when you open the switch up, that magnetic field collapses and it generates a huge voltage. In fact, when I first tested this out, I didn't have the diodes in, and my computer speakers were popping as I was letting go of these switches, so make sure that you've got the diodes in. But basically, if this looks a little confusing, it's pretty simple. It is 2 H bridges, each one connected to a coil on the bipolar stepper motor. And this is a motor I pulled out of an old scanner. I don't know where it came from. I don't even have a part number for it. But if you do come across a bipolar stepper motor, you're not sure which coil is which or what the wires do. If it is 4 wires, you can just ohm out the coils. So attach an ohm meter to one wire and then connect the other side to the other wires until you come to some resistance, right? So 5-wire unipolar stepper motors can be kind of tricky. You actually have to just hook them up and test them, because the center tab wire is connected on both sides of the coils. So try to find a data sheet if you come across one of those motors. It'll make your life a whole lot easier. So this is the setup, and basically if we wanted to control the coil with positive and minus polarity like that, we just push in this switch and this switch so that we get current like that. If we wanted to flip the polarity for something like this, then we activate this switch and this switch, okay? So it goes there, around, and then down. You really got to make sure that you don't push both of these switches at the same time, because that would be a dead short from VCC up here to ground, okay? And the same thing goes for over here as well. So now I think we're ready to go. Okay, so here's the setup, and over here we have the switches and diodes wired with 2 H bridges wired into the bipolar stepper motor, which I have here. I'll show you on the back. And that's mounted to a piece of cardboard here with a little circle and the degrees, so that we can actually see what a full step looks like, what a half step looks like. And I've got a piece of wire here mounted to the shaft so that we can watch that. So I've got 3 volts applied across the 2 H bridges. And what's interesting about stepper motors is that if you rotate the shaft, you can kind of feel the steps in there. And those are full steps. So every time you feel a little click in there, that is 1.8 degrees, at least for this stepper motor. So I have it set to 0 degrees, which locks at 0 degrees when you apply this coil here with that polarity. So it's locked in right now. Now if I rotate it, it's really, really locked in there. It's hard to move it. Okay? Now on the, like we talked about, to control it in either direction, the other coil now has to be energized. So we can go either with that polarity, and it rotates it to the left, and you can see it kind of did rotate at about 1.8 degrees. So now if I go back and then go in the other direction, oops, that was the same direction. That way, now it rotates clockwise at 1.8 degrees. And then you can sort of just walk through the sequence, okay? So I'm just alternating the polarities of these coils. And then if I ever want to switch directions, I just, oops, did it wrong that time. I just flipped the way I was doing, oops, my sequence. So it's kind of hard to do while you're talking here because you have to kind of remember which polarity you were at. Okay. Oops, let me just do that. Get it back to, get back to 0 here. Okay, now we're back at 0. Okay, so you can see how you can rotate it one direction and then flip direction just based on the sequence. And over here in your real design would be a stepper driver. So something like the Easy Driver, or something that you just feed the A naught and B naught signals, which are the signals that would drive the H-bridge MOSFETs, okay? And there's even easier stepper drivers out there that you just feed basically a square wave into and a direction bit, and then it takes care of the sequencing. And then the more advanced stepper drivers will actually handle the micro-stepping for you as well. But speaking of steps, now we can look at what a half step looks like. So right now we're locked in, but instead of letting go of this, we'll leave that locked in and then apply voltage across the second coil at the same time. And you can see that it's moving in between a step. And then if I let go of the coil on the left, now it completed that full step. So you can see that as I do this, it moves the half step into the full step. Okay, so now let's go in the other direction. Okay, so I apply it, it's in between there, and then I let go of the left side, and then it completes the full step. So now let's go this direction, and I'll show you. We'll just keep rotating it. Okay, so we're controlling that in half steps. So right now, what's one of the nice things too about the half steps is that since I'm applying here, before I was measuring with just one coil energized, it's about 0.5 amp. With both of the coils energized, it's pulling about 1.16 amps here. So you will need more power to half step too as well. But the other thing too though is when you have both of these coils energized, its holding torque is even more significant. So that's another thing to keep in mind. But basically that's the idea there, and this kind of helps you understand, you know, what the switch is and what the H-bridge is actually doing to control the stepper motor. So now from this you can write your state machine to control a stepper motor if you wanted to do it discretely with MOSFETs, which I may do here in a part 2 video. But anyway, that's just a quick and dirty video on stepper motors. Thanks for watching.